The purpose of this video is to assess whether a single 15-minute individual coaching session will have a significant effect on students' bowling scores. So, our null hypothesis is that a single 15-minute individual coaching session will not enhance students' bowling scores. Our alternate hypothesis is that a single 15-minute individual coaching session will enhance students' bowling scores. We are looking at a paired sample because each subject is being measured twice at two different times. We have the before they have the 15-minute session, and then we have the after they have the 15-minute session. And we're trying to see if the difference of the means between the pairs of measurements is zero or not, if it's statistically significant or not. So we want to run a paired samples test. But the requirements to run one is that the dependent variable is continuous, that the subjects in both groups are the same, that it's a random sample of data from the population, that there's a normal distribution. If there's not a normal distribution, then we would run the Wilcoxon test, and that there are no outliers. Per the assignment, we're going to assume that all of the requirements are met, and we're going to run a paired samples t-test. So, in order to do this, first we have to prepare the data, and we first have to calculate the difference between the scores before the 15-minute session and the scores after the 15-minute session. So, in order to do that, I'm going to click on this move column, and I'm going to go to transform compute variable, and I'm going to call this difference because it is going to be the difference between um, the previous score and the uh after the 15-minute session. So I renamed this difference, and then as you can see, I set my expression to calculate the difference by subtracting the after score from the previous score. And then I hit OK, and now I can see the difference between the two scores. While I'm at it, in the next column, I'm going to just go ahead and I'm going to calculate the um, the percent change of the scores. So it's similar. I'm going to go to compute variable, and this time I'm going to call this the percent change, and I'm going to put in the formula for percent change, which is where I'm going to calculate the difference, and then I'm going to divide that by the pre-score and then multiply that by 100, and that's going to give me the percent change. And so I have my percent change right here. So I can see what is the percentage of change between their pre-score and their post-score. Now that I have my data prepped, I can go ahead and run the paired samples t-test. So I'm going to go to Analyze. I'm going to go to, I'm sorry, I'm going to go to Analyze. I'm going to go to Compare Means and Proportions, and then I'm going to go to Paired Samples t-test. Now, from here, I already have it done because I've already kind of done this, but my first variable is going to be the pre-score, and my second variable is going to be the post-score, and then I'm going to go ahead and run my s- uh, paired samples t-test, and it outputs this chart for me. So what I can see right now is that the mean or average for the pre-scores is a bowling score of about 90, and the average for after the session is about 94. So there is a little bit of a change in the means. It's about a 5 point difference in their bowling scores from pre to post. I can see that the standard deviation for the pregame is about 13.54, and for the post is 14.31. The standard deviation really just lets us know how far from the mean, the numbers, the go. And so this is not a large standard deviation considering that we're looking at bowling scores. So the scores are pretty close to each other. Um, if we come down here, we can see that there is a positive correlation. This lets us know that as the pre-scores go up, the post-scores go up, but it's moderate. It's not a strong correlation. Then we can see right here on our two-sided p-value that I'm sorry, no. We can come down to this two-sided p-value to find the significance, and we can see that it is 0.108. And since it is greater than 0.05, we fail to reject the null hypothesis. Um, Therefore, there is not a significant change between the pre-scores and the post scores after the 15-minute individual coaching session. I also want to note that we have a t-value of negative 1.685. This indicates, because it's negative, it lets us know that it's below our null hypothesis. And the 1.685 is the standard deviations. So we have a negative 1.685 standard deviations below the null hypothesis, which indicates that our scores are, it's less than what we expected, also indicating that it's a small difference and it's not statistically um, significant. Thank you.